Alrighty, ladies and gentlemen, welcome to the Chapter 5, Section 2 notes for your McGraw-Hill Geometry textbook. This section deals with medians and altitudes in triangles. In the previous section, we discussed the perpendicular bisectors and angle bisectors in a triangle, and we discovered that those types of line segments come together at a single point, giving us our first two centers of a triangle, the circumcenter, which is where the perpendicular bisectors meet, and the incenter, which is where the angle bisectors meet. In this section, we're going to discuss the other two important types of line segments that exist in triangles, and we're going to find out that each of them also are concurrent lines, meaning that they each come together at a single point as well. So the first video here is going to deal with the first line segment. It should be a relatively short video, as it only covers the first couple slides of the notes. The second video then will deal with medians and introduce the centroid theorem, and then the third and final video will show a whole bunch of centroid theorem examples. So we're starting off here talking about altitudes. So this is a new-ish vocabulary word. In theory, this should not be a new word for anyone who's taking geometry, because everyone works with altitudes in middle school when they're finding area. The altitude, that's a fancy word for what we called the height of a triangle in junior high. So the altitude is a line segment in a triangle which is perpendicular to one side and passes through the opposite vertex. So for instance, if we're looking at triangle ABC down here, in junior high, we oftentimes are given these triangles and we're asked to find, the area of them. And since AC is a horizontal side, in junior high that tends to be the side that we call the base. And then we're usually given this length here, which we usually call the height. That is an example of an altitude. Okay? So if we put a fourth point here, we call this BD, then we'd say that BD is an altitude. Help if I could spell, probably. Altitude of triangle ABC. Now, there are three sides in a triangle, so there are three altitudes. Okay? Those altitudes don't always exist inside of the triangle. Sometimes they actually exist outside of a triangle. So for instance, if we look at triangle DEF, we are going to have to extend side EF in order to look at the altitude there. Okay? So this dotted line I just drew represents that side extended. And if we look, the altitude from D down to side EF is actually outside of the triangle. It's nice of my pen to screw up on me there. Okay, here we go. Okay, that line segment is not inside of the triangle. It is outside of the triangle. Okay, so that is an example of an altitude. Okay, let's call this point down here, we'll call it A. And then we can say, oh, well, AD is an altitude of triangle DEF. Okay. So altitudes can exist inside or outside of the triangle. Again, they can actually be sides of the triangle as well. It all depends on what kind of triangle we're looking at. If we're looking at an acute triangle, then all three altitudes will exist inside of the triangle. If we're looking at a right triangle, we'll have one altitude inside the triangle and the other two will be the legs of the right triangle. And if we're looking at an obtuse triangle, then, well, two of the altitudes will be outside of the triangle and one will be inside. And in which case you would have to extend them to find the orthocenter. What is the orthocenter, you ask? Well, the orthocenter, that would be the point of concurrency of your three altitudes. This is usually referred to with the letter H, sorry. Letter H is what we use to represent the orthocenter in higher level mathematics. It's worth noting that the orthocenter can exist inside or outside or on the triangle itself, depending on what kind of triangle we are looking at. Now, the applications of the orthocenter, unlike the circumcenter and the incenter, are not horribly useful to us in high school math. It tends to be a much higher level idea, the theorems that are related to the orthocenter. So pretty much we're just introducing this as a vocabulary word so that we know that where those three altitudes in a triangle come together, the point of concurrency for those three altitudes is called the orthocenter. So that's really all we're doing with altitudes. Later in the course we'll use altitudes to find area, just like we did in junior high. But otherwise, we really don't, we're not going to use altitudes very much in this section. It's really just a vocabulary word to be added to our information. So that does it for the first video. Our next video will cover medians and their point of concurrency, which is known as the centroid. Thank you very much for your time and attention. Please move on to the second video for this lesson.